Hello, everyone, and welcome to the Secure Developer. For those of you who it's your first time here, we're an inclusive community that enables and educates developers in application security. I am joined today by Seth Law and Ken Johnson, and they're going to be talking about their excellent adventures in secure code review, should I say. But before we get started, all about me, I am the community manager here and the human that works behind the scenes. So any questions, any session ideas, topics, feel free to tweet me, DM me, email me, all of the different channels, as well as you can get me on Slack. So Slack is the best way to interact today. So if you've got any questions for both Seth and Ken during the session, or even after, if you're watching this post-live recording, join the Slack, you can ask questions and we'll get them answered for you. If you're not a member, if you go to thesecuredeveloper.com, you can find all the information over there, as well as watch any of our past sessions. But again, enough from me. I really want to make sure that we get a lot of time with Seth and Ken today. So I'm going to hand over to them. So Seth and Ken, welcome to the Secure Developer.
Thanks for having us. We're excited to be here. Obviously, Ken and I are pretty familiar with the podcasting or the video casting world. So, but we've got a lot to review today. So thanks again for having us. Giving us the platform to talk more about secure code reviews and what we do on a daily basis.
I'm excited. Let's jump right in.
Okay. All right. Ken, did you want to share your screen? Okay.
I can totally do that. Yep.
Okay.
Once I figure it out. All right, here we go. Desktop 2. All right, that should look pretty good, hopefully. Let me just change one thing around real quick. Just gonna do a little rearrangement here so that I can keep my sanity as I switch between windows. All right, so now we should be good. Let me close that and go back to this. All right, so you should see the slides. Everybody good?
No, we're not seeing the slides right now.
We are seeing a white screen.
Okay, let me stop the share and try again. Okay, now can you see them?
Go. Yep.
Awesome. Oh, hey, I saw Magno Logan's in the chat.
Cool.
Cool person from Brazil. Yep. Anyway, so yeah, this is our very, very condensed hour of a 2/3 day course, depending on the location and the format. So we're going to get through what we can in an hour. And this is all about secure code review. Obviously, that's, hopefully why you're here. Seth, do you want to introduce yourself?
Sure. We'll just do quick intros really quick. I run a consultancy, Redpoint Security, and I've been a consultant for a number of years. I actually started way back in the day at iOmega, if people remember the zip drive people. That's where I started my coding career and then moved into security from there. So I do all things application security related through the consulting company now. So that's who I am.
And I am a staff AppSec engineer at GitHub. And before that, so my main job is to do secure code reviews. That's probably the most relevant bit of my the information about myself. Before that, yeah, I actually got my first start in consulting because of Seth. Seth interviewed me for that position. After that was at Fishnet, now Optiv. After that, it was Living Social, which was a competitor to Groupon. And then after that was security consulting company for about like 5 years. And now I work at GitHub. So anyways, the most relevant bit is throughout all those jobs, I've done secure code review.
Yeah. Both Ken and I have done it for a while. So we also host a competing podcast, should we say, Seth? No, not really. It's just the two of us. It's called Absolute AppSec. We talk, we interview people in the industry and talk about application security topics. We don't necessarily do walkthroughs like this. It's more of a just general discussion, general news, and whatever we feel like we want to complain about, right? So that's Absolute AppSec. You can find us online or wherever later. So yeah, let's jump into actually secure code reviews, Ken.
Yeah, and Seth's joking about the competition bit because it's so unprofessional of a podcast in comparison. So anyways, all right. So the philosophy, and this is super important. This isn't just some stuff we added. This is a reason this is in here, or there's several reasons this is in here. So when people think about secure code review, oftentimes what we'll find is, especially if they're only into this within like, we'll say 0 to 3 years, is the mentality is that you are supposed to find every single bug that exists. You're supposed to, have such a comprehensive and the next person that comes behind you in 6 months or a year, they won't ever find anything that you haven't already found ideally. And if you're running a bug bounty program, certainly the bug bounty people aren't going to find what, they shouldn't find what you didn't, right? Like that's what a lot of people believe. And to dispel that notion, all of that is untrue, right? You're going to find ideally the most critical high risk things, right? That's the reality. And depending on your time frame, you may find all of them or you may not. So that's the reality. Like we should start there with that kind of like hard reality. The other bit is one thing I can honestly say as a blue teamer defender who also participates in a bug bounty program is that my job is to make sure that the easy stuff doesn't slip by. That's my job. It is very rewarding when I find more complicated stuff, but that is also why we run a bug bounty program. So when people find something that's super obscure and takes 5 different chained attacks, that's amazing. That means our bounty program's working. Was that my job to find? Probably not. Like that within a 2 or 3 days of doing a review or a week or whatever it is. Yeah, it's not going to be what I do. So I think that that's important because it sets off the tone of the entire rest of this sort of like methodology that we're going to go through.
Yep.
And Seth, do you want to add anything to that?
Yeah, I mean, the points are up on the screen. Realistically, the reason that Ken and I actually started this course is because we found kind of a dearth of information about how people were conducting code reviews. Right? There's a lot of information on Java secure coding or .NET secure coding or secure coding in a specific language, but not the general approach that we as security practitioners use in approaching any code base. Most likely in your job, you're not going to be only exposed to one specific language or framework. And these are the lessons that Ken and I learned over the last 10 to 15 years in dealing with languages, number one, that we had never seen before as new stuff pops up. Number two, like do frameworks as they come into a language that you already know. And the systematic approach that we built to actually find bugs. So we're not trying to find everything. We're trying to find the high value and the easy stuff that should not go out the door. I mean, we're talking about things like SQL injection, right? Like we all know that that's been a problem. It's been around for a long time. We're not looking for the edge cases on SQL injection unless we have the time, but most likely we're looking for the easy stuff, the string concatenation, the other things that may be a problem that we know about, we know how to find, and we can find quickly and have a high impact or a high assurance of security with that code base. And I know I'm getting ahead of myself a little bit, Ken, but that's realistically where the philosophy came from.
Yeah, no, not at all. And in terms of like you see the bit there about language agnostic principles, the thing is what we're going to show you is basically how to become an expert at whatever you're tasked with. You may not know the language and framework you're dealing with. So the goal is to like get up to speed as quickly as possible on that, and then be able to assess based off of sort of this approach that we're going to show you. Feel confident and competent. Know you're competent when you review whatever might pop up. I've just dealt with a lot of things recently that I had never dealt with before. But again, following this approach, hit the wrong thing here. Following this approach, it actually helped out quite a bit. So our experience and stories and the interactive exercises and all that stuff, it's getting cut out. Really, this is all about I'm trying to minimize for an hour. So we're going to go right into the like code review bits here. So everything that we talk about, it all comes back to what we've jokingly called the Circle K framework. If you don't get the reference, it's Bill and Ted's Excellent Adventure related. So that's why we call it that. A lot of our stuff is obscure, these references, but that's why we call it the Circle K framework. Whatever you do, you always come back to this. really, I think the first one's easy. You open a file and take notes, right? Which we're actually going to show you how to write notes, like how to get your notes up to snuff, like how to get them to the part where, or to the point where you feel like you've done a comprehensive review and you've given everybody else good information on what has been assessed. But to do that, you need to get to know the application. You need to map the application, brainstorm risks. We're going to talk about that and why you need other people to do that. This is not a solitary thing. These code reviews, you need other people, that's for sure. Build your list of things based off of the brainstorming and based off of understanding the technology stack and all that. You're going to build your list of review items, perform all of the reviews. But this number 7 is like my favorite thing to really talk about. Steps 3 through 6, you're going to redo. And the reason for that is, well, we're going to, I think in this one, we do share an example of like a story about this, but it's always a good idea to go back and just make sure that you've double checked everything and you've made sure that you've thought of everything as well.
Yeah, it's not go back one slide. Sorry, Ken. The framework itself, and we'll refer back to this. We'll share the slides out as well, Sam, and we can post them in Slack or whatever you want to when we get done with this. The issue here is that it's not this isn't a single item framework. Like when you get done with this, you can be fairly confident that you've covered the items that you initially brainstormed. But the problem is, as you perform reviews, more risks pop up as you talk to other people, as you get to know the code base even better than you did when you initially mapped the application. So we've got to repeat things at least a couple of times to be fairly confident that we've at least identified the approach that the application takes to the different components, right? Whether it's authentication or authorization, the different things that we're going to talk about. But the more that we learn about the application, the better we're going to be at brainstorming the risks, at building review items and things that we should check. So we've got to perform that last step at least a couple of times, double back to make sure that we are confident in the review that we've done. All right,
absolutely. Ken. No, yeah, absolutely. Everything he just said, totally agree. All right. So there's several different like kind of formats that you could think of. There's I once lived in this world, which is you decide how much time you spend on a review. You scope it out, you get to take your time, you do it until you feel like everything's been covered and you feel confident, which it's typically never, right?
Yeah.
Joking. But that's sort of why we came up with this methodology, is that we spend a lot of time churning cycles and like continually going and being like, oh, I don't know if I'm confident. I don't know if I'm confident. Okay, here's my review. I hope I found everything. And so at least this gives you a way to demonstrate what you reviewed, give you some sense of like confidence. The world that some people live in is you have no time at all. You might have, this is the saddest thing, by the way. If you're a manager of a security team and you're listening, we have definitely in every single one of our courses come across people who they are given, like we'll say 500,000 lines of code, just throwing a number out there. And their job is to run a scanner. That's it. Like just take the code, get it to, if it needs to compile to run a scanner or whether or not, like get it to the phase that it can be like scan it, tell it, like go through those results and then do that within a day or 2 or 3 days. That's just like, if you're a manager listening and your team's doing that, you're doing it incredibly wrong. And if you'd like more information, reach out because we'd love to explain why. And we are going to talk a little bit about, and hopefully this presentation kind of does help you understand why. But yeah, like don't do that, period. I hate it. Seth hates it. It's not a good way to run your program.
I mean, and the thing you need to realize is both Ken and I have done that, right? Like when we started doing secure code reviews, that was the approach that was given to us, is we were handed static analysis results and said, okay, you're doing a code review. And at the time that became, oh, let's just run through all of these findings that come out of the scanner and, try to eliminate the false positives. And then you've run out of time and you actually haven't really looked at the code at all. So hence the reason that comes across in that slide, right? None of these types means just run a Scanalyzer and analyze the results. You're better off actually analyzing the code itself than the scanner results.
Yeah. Yeah. And I think most of us live in this, like that last, exactly what Seth said. I mean, you're better off doing, yeah, we'll get into that. The last bit here is where we probably most of us live, which is like you have some amount of time. Maybe you get to scope, at least say like what's reasonable. Maybe that like 40 hours is fine, whatever it is. And you do your best, and that's what getting it to be optimized and efficient. All right. So what we're going to talk about are, this is sort of what we're doing at a high level. A lot of this stuff is, we're not doing it, so it's crossed out, but we're going to show you where to look, how to do that. Like, how do you find source to sync? We're going to talk about like how you kind of profile an application. We're going to talk about general vulns that kind of crop up in different sections of an app. And what we're not going to do is we're not going to teach the OWASP top 10. We're not going to talk about like, here's an explanation on these various web vulnerabilities. Like, here's how CSRF works. That's our assumption is if you're watching this, you probably know that, or there's other episodes on this on the Secure Developer podcast that maybe covered that. There's resources out there. It's not what this is about. So with that in mind, let's jump right into it. All right, so these are the steps, and they are steps. The majority of this presentation is going to be focused on those first two bullet points, which is application overview and risk assessment and information gathering. But there's a lot in there, including like note taking and what we're looking for and how to map an application and stuff like that. General concepts. One thing we talk about every single time is like I'm not going to go on like a tangent here, but give yourself flow time. I like to call it like flow time. The reason is when you're in a state of flow, like time passes. Okay. But in reality, time passes without you really paying attention. But in reality, when we do these code reviews you have to find your limit, but for myself, about 2 to 3 hours of focused work is about all I can handle before I need a good break. So usually I'll give myself like 2 hours of super focused work, and then I do something else and I come back. And the reason is in mind, and you are just sort of like going until you start finding yourself like trying to multitask, maybe check email, Facebook. When you find yourself doing that, you're out of your state of flow. So you need to
Ken, did we lose you?
go into a review is just as important as like the actual review components and steps and note taking, all those things.
Yeah. And as far as don't making it personal, that goes, don't make it personal to yourself or to the developers on the other side, right? Like, so we can talk about the report at the end and like how you don't want to be antagonistic to the developers because, that's never a good, situation to be in, but also don't make it personal to yourself. The thing that you have to realize is everyone goes through that same cycle where they start with an application, they start looking at code, or they start doing a penetration test, and they think at first, crap, I'm like awesome, I'm finding all this stuff. And then they realize, they may jump down the rabbit hole. We're going to talk a lot about rabbit holes and how we need to avoid them here today. But they jump down the rabbit hole too soon, and then they kind of hit up against a limit, right? Where they can't seem to find anything else, and they've got to go back and basically start over. Hence the reason that we have the methodology and we have that Circle K framework that we've come up with, is so that you have something to go back to when nothing else seems to work, right? It's really easy to beat yourself up and say, crap, like I'm in the wrong industry, I'm doing the wrong thing because I can't seem to find these vulnerabilities that everybody else seems to think that they can find or seems to find, even though you don't necessarily see how much time it actually takes to do this. As someone that does this on a daily basis, I can't tell you the number of times that I talk to people that aren't in the industry and they're like, man, I'd really like to see what you do on a daily basis, right? I'd like to sit and watch over your shoulder. And I'm constantly telling them, no, you really don't, right? It is the most boring thing to look at, like me reviewing code, because the amount of time that I spend actually reviewing things and going down paths that don't end up in a vulnerability is probably the majority of what I do. And this is where you can't make it personal. Just because there's not a vulnerability in that code doesn't mean that you're not good at actually identifying vulnerabilities in code. It means that the developers have actually done what you want them to do. So you can't make it personal. You can't, attack yourself. But having the framework gives you the ability to be like, okay, all right, there was nothing in authentication. Let's go back and let's look at the next thing. Let's look at everything else that's there and give the developers the kudos that they deserve when you are actually reviewing that code. As far as the other code review principles that are in there, ask questions, make sure that the developers are your friends, right? If you can't actually ask them questions, it's going to be very difficult to make it through a code review in the amount of time that you have.
Yeah, we've started standardizing inside of GitHub that the first thing you do is you actually hop on a very quick 15-minute, if need be, Zoom chat with the developer of whatever you're reviewing, feature, new app, whatever it is, to get an idea of like the app, to ask the questions. What are you concerned with? Which I think you usually discuss, Seth.
Yeah, and then that's where I was going to go is like, one of the first things I learned as being a consultant is going in to do like an architecture review of an application. And, we'd sit down and we'd talk to the different stakeholders with the application. And I got to the developer at the very end and just happened to ask this question is I'm like, hey, so what is it that you're concerned about, right? And like he pointed me at 3 different vulnerabilities in the code that he already knew about, that he wanted to have fixed, but the management hadn't given him the opportunity to actually go back and do that. I mean, basically, he wrote the report format for me because he called out these different things that, yeah, I could have found in the amount of time, like in the 2 weeks that I had there, but I may have missed 1 or 2 of them if I hadn't have asked the question, what is it that you're concerned about as the developer of the application? They know it better than you do, and they're going to have a better idea of where those vulnerabilities exist. The other thing, I did a code review. This was a couple of years ago for an online system. We were digging through it, and I happened to, find a SQL injection vulnerability. And the second that I brought it up with the development team, before I even told them where it was, I was like, "Hey guys, I found SQL injection." They're like, "Oh, was it in this web service?" And I was like, "Yes, it actually was." And they're like, "Yeah, that's old. We know it's a problem. We just haven't had time to get around to it." So again, like I could have short-circuited my findings by just talking to them first and saying, "Hey guys, what is it that you have concerns with?" So anyway, ask questions, talk to the developers, talk to the other people that have looked at the code. That's going to short circuit and limit the amount of time that you're going to have to do this information gathering and mapping.
Yeah. And with framework or code documentation, I think we show some examples here, but basically like what that comes down to is you should be, if you're looking at the Django framework, maybe take a gander at the Django security information that's available out there. If you're looking at code, there's typically, at least, not for everyone, obviously, but for a lot of our repos, we've got docs folders inside the code repository where we can look through and see whatever, UML or whatever style of diagram has been drafted, and the information. Some people have like Swagger, what is it? The Swagger.
Swagger and
the JSON. Is it JSON? Yep. I can't remember what format it is. But yeah, which documents like each API endpoint and like what parameters it takes and stuff like that.
Yeah. I mean, just like the other developers, are a good resource. That any code documentation or framework documentation is going to give you a lot of pointers on where to go. And that's what we're looking at, is we're trying to short circuit the amount of time it takes that we look at code. So yeah, we'll get into this more in the information gathering phase. Building the code, running the tests. This just ensures that we actually have all the code that we need to do the review on both of those fronts. And we'll talk a little bit more about that shortly.
Yeah, I think I'm going to skip this section, and we'll basically like what happens when you have 2 million lines of code and no time to look at it. We'll get into that because you still have to follow this methodology. That's basically the gist. All right. So application overview and risk assessment. So what you need to do first, before you really start getting into code, what you need to do is figure out a few things. The behavior of the application. We're going to show you, I think, 5 or 6 different things that some questions you need to ask. Technology stack. And I like to do a little app archaeology. Why that's kind of fun is sometimes you go through, say you're going through a Git log and you're just looking at the commit history. Sometimes you'll actually see some pretty interesting commit messages that say things like, fixing this weird security thing someone talked about or something along those lines. It's always kind of fun to
removing AWS keys from the repo, stuff like that.
Silly stuff like that, which is kind of fun. And also you get to see when major functionality has been added, and there's all kinds of cool things. You can look at the list of pull requests or issues closed and open to get an idea of what's all been tackled. I do that just because it's almost like when I say profiling, it's almost like an FBI profiler looks at a person. We do that for applications before we start really digging in, because we need to kind of get an idea what this thing does. And that's part of the behavior profiling checklist that I just mentioned that we're going to talk about, which is what does it do? What's the business purpose? Who's it for? What's the customer base look like? Internal, external, both? That's obviously going to, if you have something that has an administrative interface but is open to the public, and you have both your company users and, external users on the same system, it's all in the same system, then there might be some different concerns there than an application that has maybe the users are, it's just external users and it doesn't even do anything that scary. It doesn't hold that interesting of information, which is this third bullet point. What kind of information does it hold? That's super important to know. What's the risk that we're talking about? If you're holding, we'll say, sensitive keys or personal information or whatever the case is, it's a good idea to ask the developers, how are they doing that? When you have those initial discussions, does that concern them? What parts concern them? Again, combining sort of what we talked about when we said asking questions and reading documentation with this bit. And what are the different type of roles? That's pretty common. Users, admins, everything in between, authors, whatever permission ACL kind of thing, role-based access control exists. If it does exist, you need to know that. And then of course, this is where we go back to, if you're talking to the developers, if you're talking to the project managers or product managers, or whoever is involved in these discussions, that whoever wants this app assessed, you should definitely ask them what their biggest concerns are. I just think that's incredibly important, because you're going to find, like Seth talked about a couple slides back, that people are more aware of what the risks are than you might think. And then when we talked about just to reiterate, we had 3 bullet points: behavior profiling, technology stack, and then app archaeology. So this is the technology stack part. First, you need to know the framework and the programming language. That's if there's a framework used, which there 9 times out of 10 in my case is a framework used. It might be for Golang, it might be Mux. For Python, it might be Django. For Ruby, it might be Sinatra or Rails or something like that. For .NET, Core, there's all kinds of things that exist out there, but you need to know what you're dealing with. And also, you need to know what versions you're dealing with, because that plays a huge, huge part in all of this. The security controls, when you look at the documentation, we talked about looking at the framework and language documentation. When you look at those documentations, the recommendations or security concerns can vary incredibly wildly between, say, 1 major version or even 3 minor versions. So you just need to know what version, and then reference the documentation that's applicable there. But for now, just figure out what you're working with, what versions, and that'll give you kind of an idea where you need to go and look.
And a lot of this is going to pop up later on too. We won't get into configuration review, but the software that you pull in, or that the developers pull into an application, is very critical as far as the security of the application goes. We see this recently, all of the third-party libraries that have been exploited. So you need to know what the third-party components are. So if we go back to the code review principles, one of them was that you want to build the source. And this is so that it would pull in all of the relevant libraries, like we're talking about here as we're doing our technology stack and reviewing how the application is put together, so that we know what's actually in use by that application. If we don't build the application, we could miss some important Ruby gem, or we could miss some jar that would be pulled down that could have vulnerabilities in it that would affect the security of the application. So we need to know what those third-party components are. We need to know what's being stored in them. You can take a lot of time on this, but you can take a little time. It just depends on the complexity of the application. Obviously, the data store is important as well, just from an injection perspective, like SQL injection versus no SQL injection, or maybe it's just some sort of SSRF that you're going to be looking for. But that's all going to play into the risks that we identify for the application and building out the checklist items that we want to look at. Anything else?
Yeah, and to add to that, like, because like with we mentioned JavaScript widgets, for example, there's different risks with these things. So if you have like a sales chat widget, for instance, well, now you probably need to be concerned at how like referrers are being handled, right? You might have sensitive URLs, and that chat widget is like sending those sensitive whatever values are in the URL, or like whatever the URL might, like whatever data might be sensitive there. If the widget's on every page, it might be sending that off to this third-party site. This is why you need to know these things. And like with webhooks, there needs to be some sort of like authentication between the two, which is something to write down. Hey, look into the authentication of like webhooks. Are we doing some sort of HMACking, message integrity? Like, how are we doing that? Yeah. And then like the data store piece, it's a very different set of concerns between a NoSQL injection database and like Redis. Right. I mean, there's a big difference in what you're looking for. So you need to know that in advance before you go, spending too much time going down a rabbit hole, or just completely missing that potential attack vector. Yep. That did not go to the next one. There we go. Right. So this is then the app archaeology bit, which is part of it's looking at documentation. Part of it's looking at unit tests. So people kind of always seem to forget, or I shouldn't say people always forget that, but when we bring this up, people are kind of like, oh yeah, I didn't think of that. So unit tests are incredibly helpful. We're going to show an example here in a second. Like, they give you an idea of how the application should behave, what endpoints exist, what users are doing, what the expectations are of the application, and sometimes what the expectations are not, meaning like sometimes if you're super lucky, you'll even see tests that are, testing that like the authorization is working properly on an endpoint, which is not, it's pretty rare, but it does happen. Yeah. So it's good to definitely take a look. Yeah, and then bias towards Git does allow some of the like the digging, the archaeological digging.
Yeah, like Ken was talking about before. On the unit test though, that like the great thing about the unit test is it tells you what is important about the application, right? What is it that the developers want the application to do? So you can kind of flush out, your overview of the application by looking at the unit tests. Hey, it looks like there's always some, they always test like log in and log out. That's a pretty standard one. But also, once someone's logged into the application, what is it that they expect should be working? And you can use that to almost build out your map of the application in the next phase. But at the very least, running those unit tests gives you, or looking at the unit tests gives you exactly what Ken is saying, a good idea of how the application should behave.
Yeah, and I mean, this is a good example. Like this, we have in our course, we have these different open source applications that we, that we both review and go through, but also like people choose from huge lists or whatever they want. And at the end, we do this exercise where everybody pairs up and actually puts this methodology to the test. And one of those apps is Keystone, which is you're looking at. And one of the things here that's, oh crap, I didn't mean to do that. I clicked on it. Hold on, I'm sorry, everyone. Can you still see the slides?
Yeah, we're okay. Just keep going. You're good.
All right. And it's kind of weird looking, but whatever, it'll work. So yeah, actually that is bothering me. Why is it not full screen? What happened? Did I do something wrong? Hold on. Give me 1 sec here. I'm going to fix this because it's going to bother me. I know. Being too picky, but don't like it. Just one other second. All right, let's present and then share. And then we should be good. All right. Do you see it?
Yep, we're good.
Cool. Sweet. Awesome. So this is just an example of, it's not really, there's nothing like mind blowing here, but what is interesting is this immediately tells us, hey, there's an admin part to this application. We didn't know that before. We're not running the application. We're not looking at the application dynamically. We're just like, all we have is this like written material, which is source code, right? So this immediately helps us know like, oh, there's this admin UI or this admin URL to get into the admin UI, and like, here's the location. And once you sign in, it does this redirect using that from parameter. Is that from parameter vulnerable? Add another thing to look at. Just, these are the things that are pretty cool, like to sort of get an idea of how an application works. That's one small example, but you'd obviously go through every single unit test, especially ones that, and I think we show this later, there's definitely some things that are just labeled like, hey, security thing, or, I don't know, like clickjacking test or something like that. I mean, there really are, like, it's crazy some of the things you come across. Now, when we talk about note taking, this is actually, again, a really important thing. Like, it's maybe not as super slick and cool and seems elite, but it's actually like really necessary. And I'm going to show you an example of, so we're going to show you an example that's just like the base level in these PowerPoint slides, but then I'm going to show you what we actually did with our last course we gave this. So as a group, we did this together in the morning of our second day. We actually followed this methodology together, and we built a actual checklist. And we do that in all of our courses, but I'm going to show you the last course, like what we came up with. So you get a real view of what that looks like. So the things you'll typically see in this, all of this is like, you can change this however you want. But I like to have the commit number. I think that's actually a super important thing. I like to have the commit number because it tells me, like, if you can get that get commit number. The reason I like that is it says at this point in time, this is what code I looked at. If any other thing happened after that, I don't know about it. Like, this is what we reviewed. If I come back and review this in a month or whatever the case is, I now know the last commit point to the newest commit point, that delta in between, what to look at, like what's important. I can now see what has changed, and that makes my life easier. So that's incredibly important, and please always put that in there if you can. Yep. And then you'll have your actual findings, which is a separate thing. And then you'll have your notes from the review, which is the part we're really focused on. So it's easiest if we just show that. So on the right side, it looks kind of like what I'm showing you here is actually on the left and right. It's actually one, when I do my job, because I work at GitHub and I write up my findings in issues, this all goes into the same spot, right? So it's an issue comment that has at the top my findings, and then a little separator, visual separator with all of the notes. And I actually do explicitly put on there notes for the AppSec team only, meaning feel free to ignore if you're a developer, but our team needs to see this information. So that's cool. That's kind of what it looks like. Let me stop the share and actually bring up a real version that we had from our last course so that it's a little bit clear.
Yeah, and this real version, like when we do the walkthrough, we've got a vulnerable application that we look at. In this case, I think it's Django is the one. It's like a vulnerable task manager that we review. But you'll notice that it is in the same format, right? We've got the behavior, all those questions that we talked about before, as well as as you scroll down, I'll let Ken talk to it. He's the one that filled this out. Ken, are you still there?
I'm sorry, my audio is all choppy. Yeah, my audio is all choppy. I don't know, my Wi-Fi probably. Yeah. Sorry if I interrupted unintentionally. Okay, you're still there. Cool. Yeah. So we got the commit number that we assessed at, and we answered the questions that we talked about. Like, what does it do? It's a task manager. Who does it do it for? Internal and external customers. Cool. Nothing mind blowing there. what information will it hold? Now, this is where it gets interesting. It will hold information about users, so like PII, tasks that might contain sensitive data. Now, where this got interesting is that when we realized that there's an internal and external customer base, and that this is a task manager with projects and with notes on those projects, that there might be a risk that the very company that developed this task manager is also using the task manager to put in potentially sensitive information, maybe even security issues around the very inside of the very task manager that they're talking about. So, that was just something like from kind of outside of the box thinking scenario that we kind of all came together and talked about. So the recon of the company makeup, because of the fact that the company's actually using this task manager, and you would have to consider everything like a note, a task, a project, all of that stuff, file uploads, all of that stuff to be sensitive. And then in terms of file uploads, obviously file uploads are like typically one of your most, if it's not being uploaded to, well, even then, if it's being uploaded to S3, but like file handling is always sort of a sensitive thing. And so we've definitely made a note of it. And what are the different types of roles? We talked about factors, admins, project managers, team members. We talked about like what they, team members can do X project they're supposed to be allowed to do. And then we came up with by asking questions like what would concern us, the staff, right? In this case, but normally you'd be asking, and the file handling, all the stuff. This came from the students together and about like an XML. That's always something we get concerned about. Handling of file uploads, I should say. And then like sensitive data being exposed through like IDOR, insecure direct object reference, business logic, like, being able to, come in and mess things up, I think is what that was about. I don't really remember. But yeah, so that's pretty cool. We have at least now ready before we even go into our brainstorming section down here, which we'll talk about in a second. We did the basic stuff, like here's an ORM, an object relational mapping. Is that what? Oh my God, how am I forgetting ORM? But yeah, so we know that the ORM library is MySQL client, which is important, right? Want to know.
Yeah. It's pretty simple. There's probably more third-party components that are involved here. Sometimes like we said, we'll probably, like if there's 300 third-party components, we're probably just going to pull out the ones that we're interested in that may have some sort of security issue. So in this case, it was like, hey, MySQL is the ORM client that's being used by Django. We know that could have SQL injection involved with it. So maybe let's call that one out. Again, this is kind of a compressed review, so we didn't have everything that was in there anyway.
No, and actually it's good to know that, and we talk about this down here, like why would the ORM come into play? But for those that aren't familiar, and because I know President Beef is watching, because I saw him on Slack make a comment, and I know he's watching this. President Beef is the person Justin Collins, who wrote Brakeman, which is like a open source Rails static analysis tool. He has this, like, between Rails 3, Rails 4, Rails 5, the different insecure methods of the ORM, the active record ORM, like insecure by default methods, like functions, if you use them, for instance, like .pluck is just immediately, or used to be anyways, vulnerable to SQL injection just by if you put user input into it. And some methods can just be used insecurely. So that's why it's important to know, like, okay, what is, in this case, like, what's the ORM? And then what are the things we should be worrying about? And when we talked about looking at the framework documentation, when you look at the framework documentation for Django and the ORM, it specifically tells you, like, here are ways, meaning unsafe ways, raw SQL. So these are the things we get a little bit concerned about, which is like raw, extra, execute. These are the things now we need to look for. We know we need to look for. Now, when you get to this brainstorming and risk section, Do this with somebody else. I cannot stress that enough. Do that with somebody else. Don't do it alone. Like, feel free to start filling it out alone, but jump on a call with one of your coworkers and talk through this, because what we just as an experiment at like where I work, one of our folks brought two people, myself included, of like the risks that they were concerned about in an app. Guess what? We all thought of different risks. We didn't come up with any of the same stuff. And that's the important part, is why that's important, is you need to get other people's input, because they are very likely to think of something you did not. So the more, the better. This is a thing, why not code review? That should also be social. Anyways, enough of that tangent. Again, going back to like the framework documentation, when it comes to like, okay, how do you typically these frameworks have maybe templating for their views. Like, they'll have templates. Ruby has ERB, Django has I think it's like still just .html, but it's got like the Django code inside of it. Like, so it's when it's being rendered at runtime, it's like showing both the code that's dynamic as well as the static content.
Yeah, it's got its own templating language. Yep. Are
certain functions that the documentation tells you are insecure. What's that, Seth?
No, it's got its own templating language, right? And that's what you're talking about there, is those are the tags that you want to search for, right? So you would have pulled that out of the documentation itself for Django templates.
Yep. Yeah. And then once you've created your list of brainstorming risks, create a checklist. Now that says like, here's what these are the things we're going to look for.
Yep. And this isn't a complete checklist.
We're getting mapping and routes next, and I probably should start.
Bring up let's talk about mapping next, right? So basically we're actually, documenting everything else out, as far as, that we use that template, and I use that template on a, almost a daily basis to actually push things out. I know Ken does as well. You can tweak it to your specific instance, or, what you like to see, how you like to do it. But each of those different items has got to be in there somewhere, is basically what it boils down to.
Yeah. Yep.
Cool. Yeah, I mean, we already looked at Keystone a little bit. I think, the VTM review, we've talked about each of these. So let's move through. Let's get on to mapping.
All right.
Information gathering.
Yeah. So when we talk about information gathering, there's mapping. And for that specifically, like, again, you need to know what you're working with. We give some examples here of like Node.js. Here's where your routes typically get defined. We talk about Java and .NET, and Rails, and everything else. And we talk about like how to find where endpoints get defined. Because when you talk about source to sink, that means the entry point of where a request starts. Like, you send a request off to an application. The application gets that request. What does it do next? Well, first you need to look at like where it's defined its routes, because from there it's going to say, okay, here's where this route goes. This is what HTTP path you requested. Now I'm going to send it to, I might hit this authorization logic filter first, and then forward it to a controller, and then some logic will be processed. And then at the end of the day, I'll make a DB query, or maybe I'll update a DB record, and that's the, and then a return, and then I return a view, and that's the end of that. That's source to sink. That's like where that request goes end to end. That's what we're talking about here. You want to do that mapping. And they typically do have these three.
Yeah. Sorry. The one thing that I wanted to bring up there is, I know this is very web heavy, what we're looking at right here, but that's not always the case. Or it's not like the methodology that we're talking about isn't necessarily specific to web, right? I could create the same map of, IoT applications or mobile applications, or, some sort of Windows application. It's all a matter of figuring out where the sources come in and where the sinks go out. So just because we're very web heavy, because that's what we deal with on a daily basis, doesn't mean that we haven't used the methodology for other types of applications, because it does happen across the board. Most applications, that's what they are, is some complex state engine. And all we're doing is taking the source from a user or from a file or whatever else and tracing it through to the sink and figuring out what security issues exist with that flow. So the importance of creating the map is the same whether or not the application is a web application, a mobile application, IoT, or whatever else. It all falls down, and that's why we create the map. Sorry, Ken, go ahead, keep going.
No, I mean, maybe because I'm breaking up, it might make sense to have you talk to some of this. But for this last point, it's just that, whenever you have a route, you typically do have a place where either, unless you're like, well, anybody can reach,
yeah.
But for anything that's authenticated, there's typically going to be an authorization filter that sits with that route, or that route's going to, where you hit the controller, there's a authorization invoke. So
yeah, Ken, you're breaking
the
up.
request goes in with some parameters. Yeah, why don't you speak to it, Seth?
Yeah, so the authorization filter, what Ken's saying is basically, there's going to be something that checks whether or not a person can access the endpoint that's being looked at, right? Sometimes there's different definition points in each of the different frameworks that we look at. And then once that authorization filter is passed or failed, then it goes to the logic processing, and then we trace it through all the way to the data store access, and whether that data store is, model, and then the review that's returned. So, but that's typically what we're looking at. Let's look at a couple of the examples here, Ken. I know we've only got 7 minutes left, Sam. Sam's anxious. We're not going to make it through all the content, so you're going to have to hit us up. So typical application flow, right? This is exactly what Ken, or the endpoints that we were talking about. Some sort of routing. The user is routed to a specific endpoint or a specific function. They're either authorized to access that function or not. The processing logic happens after the authorization, and then it either hits a database or external services before returning back to the user. The next example, I think, is actually Rails. So this is the implementation for Rails. So where you find the different information, right? Routes.rb, before action, before filter actually shows what sort of authorization happens on each of the different endpoints. And then the processing logic happens from there. So the before action, before filter, the route actually defines where it's going to. Show the example itself, Ken, from the code. I think it's the next slide. Yeah. Oh, I mean, yeah. Yeah, let's go to that.
Well, that's the actual, how the routes are defined. But if you want to look at if you want to look at sort of the basic gist here, where it's,
yeah. So for the forgot password route, it's a GET request to / forgot password. Which then corresponds to the password reset RB file, which has a forgot password function in it. Right, the controller is the password resets. So, yeah. I don't know if we need to talk about the
let me skip through. Let me exit out of here and skip through to one bit. When it comes to mapping, one thing I want to just real quickly show is that why does that matter? So the reason we talk. Just this, if you could walk them through that, Seth, what are we doing here with this part of the write-up? Because we talked about all of this up to here, but we have.
Okay. Yeah. So what we're dealing with on each of the different routes. So this is actually going to, drive the checklist that we're reviewing. We've got all the brainstorming and risks that we've come up with. We build out a list of the routes in the application. And ideally, we want to step through each of the routes and check the source to sink in them, right? So each of them is going to have different vulnerabilities that may or may not apply to them. Whether that's, hey, login should be required. If it's not, guess what? Then it's unauthorized. Maybe anybody can get to it. There could be SQL injection and other things that we want to check by doing that source to just sync trace. Now, if we have a limited amount of time to do this review, we may actually just be pulling out routes and endpoints that look like they have security issues with them, right? So forgot password, anything to do with authentication, authorization. And you'll see this in the actual the document that we send over and the slides when we provide them to you. But the reviews that we perform at each of those levels actually corresponds to the specific routes that are associated with authentication, authorization, and other things. We do source to sync through most of it, but when you're looking at 3 million lines of code, you've got to prioritize your time. And that's the reason that we came up with those risks initially and the checklist itself, so we know where to spend our time. It doesn't make sense for us to trace down CSRF, or maybe, in some of the applications, it's an internal application, maybe CSRF isn't a huge issue for that application, but sensitive data exposure or insecure direct object reference is where we want to spend more time, because that could be where someone would exploit and someone would actually be able to get to data and do sensitive things. And so you've got to prioritize what you're looking at. So you're looking at authorization, maybe we're not spending as much time on injection vulnerabilities or on cryptographic issues or encryption problems because of the threat model of that application. Each time that you perform a code review, you're going to be doing some sort of a threat model up front. That's what the initial discussion is about that. So this list you may or may not get through all of it. I mean, we did in this case, but we're looking at the different functions that are concerning to us, right? The upload function, download, forgot password, reset password, that's authentication. We're identifying users. The search function, because maybe we can get it to return more data than is necessary, or maybe there's, we know there's some sort of SQL interaction that's going on there. Settings, right? Why is there settings there? Maybe there's something that we can manipulate. The sensitive data exposure that could be relevant there. So each of the endpoints actually maps to that. And then we have the file mapping. Those are important files that we pull out of the application itself or the application source that may or may not correspond to a direct route map. Yeah, I think that covers the mapping section, Ken.
Okay, awesome. Yeah, no, I don't know what else there is to sort of reiterate here other than like, okay. Like Seth said, you build the list of the important files that you want to review. You build the list of the important routes you want to view. And you build a list of things you need to be looking for, like, before you end your assessment. So, for instance, we've talked about some of the like command injection, SQL injection, XSS, things that are like maybe unscoped find lookups, things like that you should be doing before you end your assessment. Now, if you've done this gives you at least some, and again, like we're already, when we do this course, we're taking over a decade of experience. Each person over 2 decades of experience between us, putting it into 2 or 3 day course. And in this case, we're putting it all into an hour. So it's a super condensed version, probably a lot of context left out of here, but mainly the point is to like build stuff.
Dang it. Ken?
If you can't get to it, that's going to be, yeah. You there?
Yeah, we
all
are.
Right. Now. I'm just going to stop talking. I think I'm done. My Wi-Fi is just not playing nice.
It doesn't like you today for some reason. No, I think Ken, what was saying is that, we're trying to give you a process that you can use and a checklist that you can use to actually step through on each of these. We'll provide the slides. It'll go, and we've actually got a white paper that we've put out on this as well. So we'll provide that over. That'll step through each of the things that we've talked about, but also it'll dive deeper into, okay, this is what you want to look for in authentication and authorization. So as you build out your checklist items, you can be fairly confident that you are reviewing the vulnerabilities that apply to each of those different kind of overarching security principles that you should be looking at. Obviously you've got your like confidentiality, integrity, and availability triad. You've got your AAA, your authorization, authentication, and auditing that you're all going to be looking at when you perform a review. But you want to make sure that you are checking for the vulnerabilities that are relevant for your application. And that's why this checklist is so important, is you want to build that as you look at the application, as you map it out, and then you want to go back through and perform each of those reviews. We didn't really get into any of the actual like review items themselves and the specifics, but this is that's the general framework that we're talking about. Go back to the Circle K framework and the actions that you perform. Go back through the methodology so that you are understanding the application and actually building out the review items before you jump in. It's very easy to go down the rabbit hole and to actually look at things before you really understand how the application works, and that's what you want to prevent. The more time that you spend up front getting to know the application, the better your code review is going to be. And I think that probably summarizes it, at least as much as we're going to be able to today, Sam, right? In an hour. So I hope it was somewhat useful to you, or at least interesting. Were there questions? We never even asked that. Were there any questions that popped up?
It was perfect. I know Ken's been on the channel also answering questions as they come up. I think the most critical question was, when is your next sort of training, and how do people sort of get involved in what you're doing? I know that, Ken, you did respond on the Slack, but for anyone listening who isn't on Slack, like where can they find out about your training, and when is the next one?
Yeah, so we've got a couple of them coming up. So at both the Global AppSec, DC, Global AppSec, Amsterdam, we're offering the training, the 2 day, 2 days at DC, 3 days at Amsterdam. We're excited about the 3-day one because it'll give us more time to actually dig in and give people hands-on. AppSec Day in Melbourne, that's in October. Black Hat Europe in December, we'll be doing it there. But you can hit us up, like the resources, like we give this away, right? It's not, this is not a secret, right? Like we want people to be able to do this. So if you hit us up, we'll share out the document, the slides with you as far as the process itself. Hit us up on Twitter. I'm at Seth Law, Ken's at CK Tricky. You can, ask us questions, hit up our DMs. You can join the podcast, whatever it is. Any of those ways, because we want you to be successful at this. We spend a lot of time spinning our wheels on code reviews, and it's not fun. Like we know that it's not fun to spend a whole bunch of time doing something that isn't super effective. So I think those are the places that you can find us, like at least over the next 3 months. But we're also at conferences and everything else. But if you follow us on Twitter, you'll see it. So
amazing. Maybe we can meet when you're in London in December.
Oh yes, definitely we should. Yeah, that'll be.
We've got one more question, just about specific tools that might be able to help when you're doing manual code reviews, specifically when the AppSec team to dev ratio is high. Like, is there any specific tool that would help with manual code reviews and like scaling that process?
Oh, scaling that process and manual code reviews. I mean, I think the most efficient thing that we've seen is actually using like GitHub and Jira to track what's going on and sharing the data back out. So you see how Ken actually, they actually document that and throw that into the GitHub issue when they're doing the review so that you can see what's going on. Like, again, it shouldn't be a secret from the developers what you're doing when you're reviewing the code. The more that you actually use those kind of development tools that are out there, the better off you're going to be. The other thing that I find incredibly useful is using the IDE that the developers are using, right? It's very easy to be like, oh, I've got Atom installed. I should be able to view any code that's out there. But guess what? If you're doing a Java, Spring code review, and you're not actually pulling that up in, whatever IDE the developers are using, you're not going to have the same level of expertise in actually viewing that source that the developers do, and you're going to miss things, right? So if you're developing or if you're looking at a .NET Core application, use Visual Studio. Yes, I know it costs money as a consultant, but it's going to be worth it in the long run. And that's not to say that we don't use some of the automated tools, right? At times, like Ken mentioned, Brakeman, right, for Rails, or some of the open source ones that are out there, like JavaSec Find Bugs, PumaScan for .NET. There's tools that are out there that actually speed things up and give you pointers. Just don't depend on that solely. That's my automated tool speech.
Yeah.
So.
And again, Ken's you've kind of answered this, but we had one which I think might be a bit of an open-ended question. But which tech stack have you found the most security risks with? I'll see if you
most security risks. PHP.
I said basically anything Java. Well, yeah, PHP. Okay, PHP wins. I didn't know PHP was making its way into this conversation. You're right.
Oh, yeah. But yeah,
may the best man win.
Yeah. I think it's whatever you've seen the most, that's what you find the most vulnerabilities in, right? Like so it's easy for Ken to identify vulnerabilities in Rails because he's a big Ruby Rails guy, right? Like my side, like Python or even like iOS, I find a lot in there because I've developed a lot in those different frameworks and for those different platforms. And so like definitely your expertise help, but you can still find the documentation and find vulnerabilities and other things. So we can argue about that on Twitter if we want to.
Let's take it back to the Slack. But thank you so much, both of you, again, for being involved today. I know it was a very short period of time, but as you said, anyone listening, you can catch these two at a lot of conferences or hit them up directly or pop your questions in the Slack group and we can loop them in and get them answered for you. Hopefully it also won't be the last time they're on the Secure Developer, and so we'll have a lot more sessions coming up with some more information. But yeah, thank you to both of you.
Yeah, thank you for having us.
Yeah. Perfect. And then for anyone listening, our next session is in 2 weeks' time, as promised, on the 26th of August. It's with Scott Helm, and he's going to be talking from zero to hero, deploying HTTPS with the quick and easy way. So if anyone's interested in that, please join us. It'll be fun. It'll be great. And that's enough for me. Just a reminder, obviously, that the Secure Developer is brought to you by Sneak. They are the company behind us who are helping us keep this platform vendor neutral and give out content. So huge thanks to them. And that's enough from us. We'll see you all next time.
All right. Thank you.